Welcome back, everybody, to your second video lesson for Algebra 1, Unit 1 on expressions and equations. Today we're going to focus on translating verbal phrases into mathematical operations. So as we go through this, make sure, just like last time, take out your notes and take good notes and ask plenty of questions. Write those questions on the side. We're going to jump right into this one. So here we go. Alright, so the purpose of this lesson today is we're going to look at translating verbal phrases, meaning if I were to give you a problem, whether I describe it to you in words or something that you have to read, what you have to be able to do as a good math student is be able to translate something from words and write it down as a mathematical operation or as an expression. Okay, so here's kind of a list of things you might see, especially when you read a problem. Okay, you have really the four basic operations that we can do: addition, subtraction, multiplication, and division. So in these columns you can see some words that can be used when we actually write down a problem in words, something you might see in a word problem. So for example, you have addition, you have the ideas of sum. Sum means add, plus, total, more than, increased by. So if you see any of these words, that automatically tells you in a problem you're going to add those things together. All right, the next column you have subtraction. So kind of the opposite of addition, you have difference, less than, minus, or decreased by. All of those are going to represent subtraction. Multiplication, you have times, product, multiplied by, of. Now the last one here, you're going to pay attention to of. Of's a tricky one to remember, but these words are going to represent multiplication. And then lastly, you have division, quotient, divided by, divided into, per. Per is one you'll see a lot as well, something we'll work on today. All of these represent division. So again, these words are going to be used within problems, within a description of a problem that you're going to have to be able to decipher and write down a mathematical expression based off of that. Okay, so let's practice some of these, and again, you might have to refer back to the table we just went through. So what I want you to do, we're not going to simplify anything. All I want you to do is write down the mathematical expression based off of what we are seeing in this problem. So the first one, we have 3/4 fraction of a number. 3/4 of a number. So first of all, 3/4, we're going to start with that. Then we have of. So if you look at your list, what is of? Okay, 3/4 of means multiplication. So I have 3/4 times a number. Now I want you to think, when I say a number, what does that mean? What are we representing when I say a number? I don't know what number it is, so it could be any number. So how do we label something that we don't know? Well, we're going to label this as x. So 3/4 of a number would be 3/4 times. Now I'm going to use a dot here just to differentiate between times and the x, but 3/4 times x. Okay, next problem, we have 5 less than a number. Now, we see the term less than. What does less than represent? If you check your column, less than represents subtraction. Now, this one's a little tricky because we have 5 less than a number. So whatever our number is, we're going to be 5 less than that. So how do we write this as an expression? Okay, 5 less than a number. Well, you have really two ways. You could do 5 minus x, or x minus 5. So which one would represent 5 less than a number? Okay, so your result, if you think about taking 5 away, your result is going to be smaller. So the one that makes the most sense is the second one. So this one on subtraction, when I say less than, I place that number after. Okay, after the x, after the variable. So 5 less than a number would be x minus 5. Okay, next one, quotient of 7 and a number. Quotient of 7 and a number. Quotient means division. So I'm not dividing. Dividing what? 7 and a number. So I'm going to find the quotient of 7 and a number. So in this case, the quotient means division. So I'm going to have just simply 7 divided by a number, which is x. 7 divided by x. Is that the only way to write it? No, I could have wrote it as maybe a fraction. 7 over x. That also represents division. Okay, so there's multiple ways in which you can write that. Quotient means division. Last one here, we got sum. Sum means addition, the sum of a number and 8. Now, this one's similar to the other one before, 5 less than a number, but notice how we have sum. So, the other options we have here, just like we had before, are I'll use x plus 8 or 8 plus x. So now ask yourself, does it matter here? Okay, notice how it was different up in this problem because we had 5 less than a number. So it was smaller in the end result. Now, x plus 8 versus 8 plus x. No matter what in this case, say x is 2. 2 plus 8 is 10. 8 plus 2 is 10. So do we get different results? And the answer is no. So in this case, when you have the sum of a number and 8, both those solutions work out. Okay, so what we did here is just take a verbal phrase and translate it into mathematical expression. All right, an example of when we use verbal phrases to represent a mathematical expression is something called a rate. Believe it or not, a rate is something you have experienced in your everyday life. For example, you could have miles per hour. Okay, miles per hour, otherwise seen as mph. Notice that these are comparing two things. Miles, which is distance, and hour, which is time. So you're comparing two completely different quantities here. But think of the application. What we have is miles per hour. So again, here's that verbal phrase per that represents a specific mathematical operation. In this case, per, if you look at your list, what does that represent? Well, it represents division. So per represents division. So what we're doing here is we're taking miles and we are dividing them by the number of hours we're traveling. So for example, if I have 24 miles in 2 hours, that's going to tell me something. That is what's called a rate. Now, when we get something like 24 miles for every 2 hours, okay, yeah, that makes sense. But what we always hear is miles per hour. When you hear per hour, what does that mean? Well, that means how many miles that you travel every hour, every one single hour. This is a different type of rate called a unit rate. Okay, it's a rate when the denominator is equal to 1. So when you say miles per hour, the per hour representing that my denominator is 1 hour. So think of the example I gave you before, 24 miles in 2 hours. What would the unit rate be? Well, think about, you have 24 divided by 2. Well, what's 24 divided by 2? That's 12. So down here, the unit rate would be 12 miles per every 1 hour. Okay, so a rate is just an example of a verbal phrase of division, but in this case, using it in kind of a real-life sense, an application of that. All right, here's an example. A roller coaster travels 240 miles in 2 hours. So what we're going to try and do here is find the unit rate in feet per second. Okay, so feet per second. I'm going to give you a little bit of a challenge here. So what we're given is 240 miles. Gave this to you on purpose. All right, why? Because what do you notice? I gave you 240 miles, and I'm asking for feet. Oh, geez. Well, what the heck do you do here? Well, one useful tool is I'm asking you for mile, or I want you to do feet, and I give you miles. You got to convert. How many feet does 240 miles equal? So you might want to take out your calculator here. Okay, how do I convert 240 miles to feet? Well, let's just think. All right, I'm going to do a basic series of multiplication and division. What I want to do is I want to figure out how many feet are in 240 miles. So up on the top, I gave you some useful conversions. Okay, and what I want to do is convert from miles to feet. So if you look at the table, which one would I use? Well, yeah, you see 1 mile is 5,280 feet. So what I'm going to do is I'm going to multiply this by 5,280 feet per 1 mile. So 1 mile is equivalent to that. Okay, in this case, the miles drop out. We don't worry about that anymore. What we're left with is going to be 240 times 5,280 feet. It's going to give us a nice little conversion of how many feet that would be. So if you plug that into your calculator, punch those numbers, you should get 1,000, or oh boy, not 1,000, 1,267,200 feet. That is a whole lot of feet, but that's okay. So that's how many feet the roller coaster travels in 2 hours. Okay? Now, notice again the other thing I give you here is that it's 2 hours. And what am I asking you for? I'm asking you for seconds. Well, Jesus, I got to do this again. Okay. Well, so the question you ask yourself then is, how many seconds are in an hour? Well, I don't know, but I do know that there are 60 minutes. in an hour, right? There are 60 minutes in 1 hour. And I also know that there are 60 seconds in 1 minute. Okay, so hours here we don't have to worry about. Minutes we don't have to worry about. So if I just take 2, multiply it by 60, multiply it by 60 again, that should give me the number of seconds. So 2 times 60 times 60, if you punch it into your calculator, that's going to give you, run out of space here, so I'll write on the bottom, 7,200 seconds. Holy strawberries, Batman, are we in a jam here? Okay, so what did I do? I basically took the number of, what have I done, I should say. I took the number of miles and converted that to feet. I took the number of hours, converted that into seconds. Now what I want to find is the unit rate in feet per second. So the last thing, per, means division. I'm going to take my 1,267,200 feet, and I'm going to divide that by the number of seconds, which is 7,200 seconds. Holy cow, and that's going to give me feet per second. So again, if I take 1,267,200 and divide that by 7,200, that's going to give me 176 feet per second. And that is the unit rate. That is how many feet that roller coaster is traveling every second. Okay, so again, this is just an example, an application of using these verbal phrases as mathematical operations. All right, next thing let's look at is what's called an equation and an inequality. So these are going to be two of the biggest things we're going to do throughout this entire course is working with equations and inequalities. So what is an equation? You think of the word equation, first thing you might see is equal, right? An equation is a mathematical sentence, so think of those verbal phrases again, by placing the symbol equals in between the two expressions. Okay? So for example, I could say x plus 2 equals 4. Alright? So that would be an equation. I'm basically saying this expression, x plus 2, is equal to this expression, 4. Okay, now we'll talk about what we do from there, but yeah, that is what's called an equation. An inequality is not equal to, but it's a sentence formed by placing one of these symbols in between the two sentences. Now, what do these symbols mean? Hopefully you remember these. Okay, this one, what does this one mean? Well, that is less than. This one is less than, and it also has that little bar underneath. This is less than or equal to. This would be greater than, and then greater than or equal to. So we have some different phrases here we're going to have to know and recognize and be able to use a symbol for. All right, but use the same example, x plus 2, and I put in that symbol greater than 4. All right, again, I took an expression, I plugged in this symbol, and 4. It's just taking a sentence and placing a symbol, whether it's equals or an inequality symbol, to tell me that these two expressions have a relationship with one another. Okay, so here are some of the symbols you need to know. All right, so obviously the first one's equal to. It means that this symbol right here, 2 bars, means equal to. Other words you can see is same as, equal, same. One is the same as the other. It's equal to the other. This right here is less than. Okay, less than. I always think of this. I picture this as like a little sideways carrot. All right, wherever the tip of the carrot points to, that means it's less than. Some of you might have heard of like an alligator mouth before, that the opening of the mouth always goes to what's greater than, because alligators are always hungry, right? They always want to eat, so the mouth points to where they want to eat, the things that's greater than. Okay, but this one, obviously, if we're saying on the left side, is less than what's on the right side. So this means less than, or we could also say fewer than. Fewer and less are the same meaning. Okay, this one means less than, and that bar represents less than or equal to. So this one, you have an option, or. Think of pizza or chicken. You can have one or the other, but you can't have both. Okay, so less than or equal to. All right, at most, no more than. These are some other phrases we might use for less than or equal to. Then flip those, we have greater than. Again, notice how the tip would point to the right now, so this is going to tell you this side is smaller than this side, or the alligator's mouth is going to eat what's open on the left. Okay, and then this one would be greater than or equal to. Okay, now with these last four, with these inequalities, okay, the biggest things when we write these, think of how we read. How do we read things? When you read this sentence is equal to, notice you read from left to right. So when we write these sentences, when we use these inequalities, we are always going to write them from the left to the right. Okay, so that's a big thing to mention, maybe to just draw. We're always going to write from left to right, meaning these symbols are going to be somewhere in the middle. We're going to have an expression, symbol, an expression, symbol, expression. All right, now, next thing, what is a solution? So once we have an equation or an inequality, we're going to start talking about a solution to those things. A solution to an equation or inequality is a number that we would plug in for a variable, right? So say it's, go back to my example I used before, x plus 2 equals 4. We have an equation because of the equal to. So I want to know, what is a number that x represents? What number could I plug in for x to make this equation true? So that's what a solution is. It's something you substitute in, all right, that makes the result true. And this is the biggest thing. The solution will always be true. Okay? Solution will always be true. If not, then there's no solution. We'll worry about that a little bit later. So here's an example. So I'm going to use the number 8. I'm going to check just to see if 8 is a solution to the following equation and inequality. So to figure out if 8 is a solution, what I'm going to do is I'm going to take 8 and I'm going to plug it into the variable. So here, 9 times 8 minus 4, does that equal 70? I'm going to put a little question mark above the equal sign. Okay, does it equal 70? So now this goes back to a little order of operations. What do I do first? Well, I have 9 times 8 minus 4. We'll do 9 times 8 first. That is going to be 72. Then I'm going to subtract off 4. Okay, so 72 minus 4, that gives me 68. Does that equal 70? No, that does not. So does that mean 8 is a solution to this problem? This means 8 is not a solution. So this is not a solution. The way I sometimes have you label this is NS, means no solution. Okay? Same thing on this other problem. What I'm going to do is I'm going to take the number 8 and I'm going to plug it in for y. I'm just going to plug it in for whatever variable's there, whether I have a g or a y. Okay, so here I have 4 times 8 plus 8. There we go. Now, what does this symbol mean? That is greater than. So 4 times 8 plus 8, is that greater than 10? I'm going to put a question mark above that again. I'm just going to worry about the left side because this one we have to clean up. So 4 times 8 plus 8, I'm going to do 4 times 8 first, order of operations. That's 32 plus 8. 32 plus 8 is 40. So finish that off. Is 40 greater than 10? Ah, check, it is. So what does that mean? If 40 is greater than 10, this is a true statement. So that means 8 is a solution. 8 is a solution to this problem. Okay? So, key thing here, solution is if you plug a number in, whether it's an equation or an inequality, plugging that number in will make the equation or the inequality true. That is a solution. All right, so now let's kind of think about how we can solve problems. Given an equation or an inequality, what I want you to do is try and just think about these. Now, looking at an equation, I want you to really try and translate it from an equation into a verbal phrase. And this is going to help you to solve this mentally without even writing anything down, without even using any tricks or techniques to solve this problem. So when I see 6 plus y equals 14, that's literally what it says mathematically. But we think about what it means. Well, y is a variable. Variable, we usually say, what number, right? A number. 6 plus a number equals 14. So thinking about that, what would that number have to be? Well, 6 plus a number equals 14. Right, you can just count this out. Well, 6 plus, if I add 1, I get 7, add 2, I get 8, and so on, and so on, and so on, and I get to 14 eventually. So what number would give me that? Well, it'd be 8. But again, just thinking about the expression, 6 plus y equals 14, if I add that number to it, what would give me 14? I could just think about it, okay? Now in this one, next one, I have 9b equals 27. Well, 9b, they're written next to each other. What the heck does that mean when they're written next to each other? That means multiplication. So this means 9 times what number equals 27? And you can, again, think about this as a verbal phrase. 9 times what? What number times 9 is 27? Okay, so 9 times 1 is 9. 9 times 2, that's 18. 9 times 3, that's 27. Or you could think, okay, 9 plus 9 would give me 18, plus another 9 would give me 27. That's 3 groupings of 9. So here the answer, the what number, would be 3. When I say what number, these two things right here, what do they represent? The solution. Okay? So again, just thinking about how I can solve a problem verbally by just taking an equation or an expression, translating it into the words, and that can help me to figure out actually solve a problem in my head without writing anything. All right, last two examples I want you to know. Okay, we talked about verbal expressions. We did these rate examples. I'm going to give you 2 examples right here. I want you to pause the video and try these 2 problems yourself. Okay, so right now, pause the video and give it a shot. Ready, set, go. Okie dokie, hopefully pause the video. Now you can see the solutions. So top problem, we want to find a unit rate in feet per second. Key thing, feet per second, feet per second. I give you 30 miles per 2 hours. So 30 miles every 2 hours. Here's what you had to do first. Just like the problem we did before, 30 miles got to convert to feet. So I did the same conversion, 30 miles times 5,280 feet, which is the number of feet in 1 mile. That's going to give me 158,400 feet. Okay, 2 hours, we did that in the problem before, so I just rewrote it. We already did the conversion, so I didn't show it again. 2 hours is 7,200 seconds, or 7,200 seconds. So, again, feet per second, when I see the word per, that means division. So what I'm going to do is take the number of feet and divide it by the number of seconds, which I did here. And that's going to give me 22 feet per second. Feet per second. That would be the unit rate. So every 1 second, that's 22 feet. So remember, when you see the term unit rate, that means it's over 1. Something, I'll put n over 1. Okay, next example, check to see if 3 is a solution to 5z minus 8. Now what does that symbol mean? That is less than 20. So what I did here to find a solution, remember solutions when you plug it in, doesn't make the equality, or in this case inequality, true. So I plugged in 3. Order of operations says I'm going to do 5 times 3 first, which is 15. Subtract 8, which gives me 7. Is 7 then less than 20? 7 less than 20? Well, I think it is, right? So yes, that means 3 is a solution to this problem. Okay, so again, we're focusing on translating verbal phrases. We've worked in these equations and inequalities. So if you have any questions, make sure you jot those questions down. Bring them to class next period. Ask any questions you have, and we'll see you there. Get ready for your practice problems. All right, ladies and boys, peace.